Albert Einstein, the genius who transformed our understanding of the universe. With his theory of relativity, he redefined time, space, and gravity, laying the foundation for modern physics. But his legacy goes beyond equations. He was a bold thinker, a passionate humanist, and a symbol of scientific creativity. Join us on this journey through his life, his discoveries, and his impact on the world. Welcome to the story of Albert Einstein, the man who forever changed our perception of the cosmos. His name has become synonymous with genius. When we think of an outstanding scientist, his tousled mane and restless gaze are perhaps the first images that come to mind. His discoveries, especially the theory of relativity, changed the history of physics forever, and his face is almost a cultural icon. But beyond the equations and the famous photo of him sticking out his tongue, how much do we really know about the real Albert Einstein? His life was full of curiosities, moments of rebellion, musical passions, and of course, anecdotes that reveal a personality as genuine as it is irreverent. Today, I invite you to a detailed journey through the biography, thought, and adventures of this immortal genius, whose legacy continues to dazzle humanity. Albert Einstein was born on the 14th of March, 1879 in Ulm, a city in southern Germany. The son of Hermann Einstein, an engineer and merchant, and Pauline Koch, an amateur pianist, Albert grew up in a secular Jewish middle-class household with a younger sister named Maha. Little Einstein surprised his family with his slow speech. In fact, he began to express himself more fluently around the age of 3 and had difficulty stringing full sentences together until almost 9. His family was seriously worried, thinking he might have some cognitive delay. However, Einstein always showed an inexhaustible curiosity. There is a famous anecdote that tells how, when he was just a child, his father showed him a compass to entertain him while he was sick. Albert was completely fascinated. He did not understand how there could be an invisible force that made the needle move without apparent physical contact. Years later, he himself would point to this event as a trigger for his obsession with unraveling the mysteries of the universe. Music also played a fundamental role in his upbringing. His mother, Pauline, encouraged his musical talents, starting him on the violin. According to his sister Maja, Albert could spend hours playing pieces by Mozart, using them as a kind of meditation to clear his mind. In fact, years later, he would say that if he had not devoted himself to physics, he probably would have been a musician. This blend of art and science would always accompany his way of perceiving the world. If there is one word that describes Einstein in his youth, it is nonconformists. His school years in Germany were marked by continuous clashes with the educational system of the time, which was mainly based on memorization and rigid discipline. Albert believed that this methodology crushed curiosity and free expression, so he often got into conflicts with his teachers. It is said that one of these teachers, tired of Einstein's undisciplined attitude, once told him, "You will never amount to anything in life." What great irony! But that's how close the criteria were for measuring intelligence and creativity at the end of the 19th century. His frustration reached such a point that he left school without a formal diploma. Shortly after, his family moved to Italy, and he saw an opportunity to escape from that stifling educational environment. After some ups and downs, Einstein managed to enroll at the Federal Polytechnic School in Zurich. This new environment, much more liberal and with an emphasis on understanding concepts, was refreshing for him. There he met Mileva Maric, a Serbian student with whom he shared not only physics and mathematics notes, but also a deep intellectual connection. They fell in love and eventually got married, although over time their relationship would go through severe personal crises and end in divorce. In his first attempt to access the Polytechnic, Einstein failed subjects such as botany and French, which he did not consider relevant to his future scientific career. However, his brilliant performance in mathematics and physics was so notable that he was admitted. This anecdote perfectly illustrates his character. For him, passion and curiosity were what really counted, and if something did not capture his interest, he simply paid it no attention. After graduating, Einstein did not immediately land a teaching or research position in academia. He ended up working at the Federal Patent Office in Bern, Switzerland, as a technical-level patent examiner. This job, seemingly unglamorous, gave him a stable schedule and space to reflect on his ideas without the pressures of a university environment. And it was precisely in 1905 when Einstein, at 26 years old, published 4 articles that shook the foundations of physics. This period is known as his Annus Mirabilis, miracle year, and marked a before and after in the history of science. First article, Photoelectric Effect. The first text, published in March 1905, addressed a phenomenon that intrigued many physicists, the so-called photoelectric effect. It was known that light, when striking certain metals, could eject electrons, generating an electric current. However, classical physics could not fully explain the observations. Einstein's genius lay in proposing that light not only behaves like a wave, but can also be considered a set of small packets of energy called quanta or photons. When these photons hit the metal surface, they release electrons with energy proportional to the light's frequency. With this idea, the foundations of quantum physics were laid. Years later, in 1921, the Nobel Committee recognized this monumental contribution by awarding Einstein the Nobel Prize in Physics, curiously not for relativity, but for his explanation of the photoelectric effect. Second article, Brownian motion. The second article delved into Brownian motion, the random movement observed when small particles like pollen grains float in a liquid or gas. Although the existence of this movement was already known, the scientific community did not agree on its origin. Einstein mathematically demonstrated that these oscillations were the result of constant collisions of the particles with the fluid's molecules, providing compelling proof of the existence of atoms and molecules, which were still questioned by some skeptics of the time. Thanks to his work, atomism became a key piece of physics and chemistry, reinforcing the view that matter is composed of tiny particles. Third article, Special Theory of Relativity. The third of his articles is, without a doubt, one of the most famous, the special theory of relativity. Until then, time and space were assumed to be absolute, following the legacy of Newtonian physics. Einstein, considering the constancy of the speed of light in any frame of reference, realized that time and space measurements depend on the observer's speed. According to this theory, there is no privileged frame of reference, and the notions of simultaneity or duration change according to the relative speed of the observer. This was a radical blow to classical physics and represented a completely new way of understanding the universe. The concept of absolute time ceased to make sense, opening the doors to a new cosmology in modern physics. Fourth article, E equals mc quadrad. The fourth and final article, published that same year, contained one of the most famous equations in the history of science, E equals mc quadrad. In this work, Einstein addressed the equivalence between mass and energy. The equation expresses that a small amount of mass can be converted into a large amount of energy and vice versa, since the speed of light c is a very large number. This discovery laid the theoretical foundations for nuclear energy and opened a range of technological possibilities. However, it also implied a double-edged sword, as decades later, it would be applied in the construction of the atomic bomb. Thus, E equals mc quadrad transcended the academic realm and became the icon of a new scientific and technological era. It is said that, while working in the office, Einstein reviewed patents from inventors who presented all kinds of gadgets. Amidst the paperwork, he would pull out a notebook where he jotted down equations and reflections, as if inspirations came to him in the midst of routine work. Those brief moments of calm turned into a cycle of articles that would change the course of scientific history. Einstein's career did not stop in 1905. He continued developing his ideas, and in 1915 he presented his masterpiece, the general theory of relativity. In this new theory, he reformulated the concept of gravity, ensuring that it was not a force in the traditional sense, but the result of the curvature of space-time generated by mass. Initially, many scientists showed skepticism, but in 1919, the British astronomer Arthur Eddington led an expedition to observe a solar eclipse and verify the deflection of starlight when passing near the sunday, as Einstein had predicted. The results confirmed his theory, and the news traveled the world with headlines like "Einstein topples Newton." Overnight, Einstein became a global celebrity. In 1921, The Nobel Committee for Physics awarded him the prize, but curiously not for relativity, which still seemed too controversial for some, but for his explanation of the photoelectric effect. Einstein, with his characteristic sense of humor, joked on more than one occasion that the committee members were perhaps waiting for some additional proof before recognizing relativity. Albert Einstein, who was not only a physics genius but a convinced humanist, remained firm in his pacifist stances and his rejection of all forms of authoritarianism. However, with Adolf Hitler's rise to power in 1933, Einstein, of Jewish origin, had to leave Germany. His books were publicly burned, and his scientific work was denigrated as Jewish physics. The persecution against him forced him to go into exile in the United States, where he settled in Princeton, New Jersey. His escape was not just a personal matter, but also a turn that impacted the world of science, as other brilliant minds also fled Nazism, contributing to the rise of physics in the United States. During the early years of World War II, Einstein signed a letter along with physicist Leo Szilard to alert President Franklin Delano Roosevelt about the possibility that Nazi Germany could develop an atomic bomb. Einstein was a pacifist and always regretted having contributed, even indirectly, to the nuclear arms race. "Had I known that the Germans would not succeed in developing an atomic bomb, I would not have lifted a finger," he once said. Although he did not participate in the Manhattan Project, that letter was a key factor in its initiation. Remorse would accompany him for the rest of his life, turning him into an activist for peace and a critic of nuclear proliferation. When we think of Albert Einstein, it's easy to imagine him in front of a blackboard filled with complex formulas or receiving ovations at scientific conferences. However, his everyday life was full of endearing and sometimes comical anecdotes. Einstein was famous for being absent-minded. One of the most repeated stories is that he often forgot the keys to his house in Princeton, leaving him locked outside. His neighbors knew him well and would offer to help him climb through an open window, while he laughed at his own lack of organization. Einstein's passion for music never waned. He took his violin to meetings and academic gatherings. It is said that he sometimes livened up the conversations with pieces by Mozart or Bach. He even confessed that when he was stuck on a scientific problem, playing the violin helped him sort out his thoughts. A curious hobby of Einstein's was sailing a boat, despite never really learning to swim. More than once he ended up capsized in the water and needed help rescuing the boat. He was so relaxed about everyday activities, preferring to focus on what he was passionate about, regardless of practical details. Although he disliked being pigeonholed in quotes taken out of context, several of the phrases attributed to Einstein have become iconic. Some of the most famous are, "Imagination is more important than knowledge." He said that knowledge has limits, but imagination opens doors to yet unknown realities. "I have no special talents. I am only passionately curious." This quote shows the humility with which he faced his own genius. "If you want different results, do not do the same things." A call for innovation and to break the routine. "Science without religion is lame. Religion without science is blind." A reflection on the need to integrate reason and awe in the pursuit of truth. Interestingly, Einstein, one of the founders of quantum physics, with his explanation of the photoelectric effect, had notable disagreements with the way this new branch of physics evolved. His famous debates with Niels Bohr at the Solvay conferences are legendary. Einstein could not accept that nature operated at the fundamental level through pure probabilities, as proposed by the Copenhagen interpretation. During one of these meetings, Einstein expressed his skepticism by saying, "God does not play dice with the universe." To which Bohr wittily replied, "Einstein, stop telling God what to do." With that comment, Bohr encapsulated the stance of the defenders of quantum mechanics. Reality can be fundamentally uncertain at the subatomic scale, and this is not a mistake of the theory, but an essential feature of the universe. These exchanges were not mere academic discussions, but intellectual clashes between two giants trying to unravel the ultimate foundations of reality. Einstein was never entirely comfortable with the probabilistic interpretations of quantum mechanics, and spent the last years of his life searching for a more deterministic unifying theory that would resolve his discomfort: quantum chance. To understand the relevance of Albert Einstein and his influence on scientific culture, It is important to look at the context in which he developed his theories and how he related to other great scientists of his time. The turn of the century, between the late 19th and early 20th centuries, was a time of effervescence in the world of physics, marked by debate over the nature of light, the structure of matter, and the validity of classical physics. At the end of the 19th century, physics was considered practically closed in some areas. Newton's model satisfactorily explained most everyday phenomena, and thermodynamics had made great advances. However, certain experimental results such as the blackbody spectrum or the photoelectric effect began to challenge the traditional view. At the same time, the existence of ether as a medium for light propagation was being questioned after the Michelson-Morley experiment, which detected no difference in the speed of light, regardless of the direction of measurement. In this breeding ground, figures like Max Planck, who introduced the quantum of action to explain blackbody radiation, and Hendrik Lorentz, or Henri Poincaré, who studied mathematical transformations to describe electrodynamics, emerged. It was in this environment that Albert Einstein burst onto the scene in 1905 with his special theory of relativity, while working at the patent office in Bern. Max Planck, considered the father of quantum theory, played a fundamental role in the initial recognition of Einstein's ideas. After the publication of the article on the photoelectric effect, Planck was impressed by the audacity of that young unknown who claimed that light could be composed of quanta photons. Although Planck was reluctant to abandon classical physics entirely, he publicly supported Einstein and helped him integrate into more prestigious academic circles. It is said that Einstein and Planck often exchanged correspondence, in which they mixed deep reflections on thermodynamics and quantum theory with personal anecdotes. This closeness facilitated the consideration of Einstein's ideas by the German scientific community, the most influential at the time. Despite being considered the great architect of relativity, Einstein was not the only nor the first to think about the need to adjust the concepts of space and time. Henri Poincaré and Hendrik Lorentz had published work suggesting a new conception of relative time. However, it was Einstein who made the definitive conceptual leap by eliminating the idea of absolute time and declaring the speed of light as a universal constant. Another key figure was Hermann Minkowski, Einstein's former mathematics professor, who formulated the idea of space-time as a four-dimensional continuum. Einstein initially resisted Minkowski's geometric perspective, but later adopted and expanded it to develop the general theory of relativity. From 1911, the Solvay Congresses became the meeting point for the great physicists of the era. At these meetings, figures like Marie Curie, Ernest Rutherford, Niels Bohr, Max Planck, Wolfgang Pauli, and of course Einstein gathered. Intense debates on the nature of matter, the atom, and the implications of quantum physics were held there. It was precisely at these congresses where Einstein and Niels Bohr starred in legendary discussions. Bohr defended the probabilistic interpretation of quantum mechanics, while Einstein pushed for the search for a deterministic theory and resisted the idea that chance was a fundamental component of reality. The famous exchange of phrases "God does not play dice" versus "Einstein, stop telling God what to do" crystallized the conceptual tension between the two views of the universe. Max Born, one of the fathers of quantum mechanics, maintained a lasting friendship with Einstein. Their letters today provide a fascinating testimony to the evolution of physics in the first half of the 20th century. In them, they discussed quantum indeterminacy, the theory of relativity, and personal matters. Born tried to convince Einstein of the solidity of the probabilistic interpretation of quantum mechanics, while Einstein responded with ingenious mental experiments that questioned the completeness of the theory. These letters reflect, better than many treatises, the intellectual effervescence of an era that witnessed two of the great scientific revolutions, relativity and quantum mechanics. In a world dominated by men, the presence of female scientists was rare. However, personalities like Mileva Maris, Einstein's first wife, and Marie Curie, stood out for their scientific rigor. Mileva, who studied physics and mathematics at the Polytechnic School of Zurich, collaborated closely with Einstein in his early works, although her exact contribution is a topic of historical controversy. On the other hand, Marie Curie, a double Nobel Prize winner, coincided with Einstein at various congresses and established a friendship based on mutual respect. In personal letters, they exchanged impressions on radioactivity and the situation of minorities in science. With the enormous prestige that Einstein began to accumulate, jealousy and rivalries also emerged. Philip Lenard, Nobel Prize winner in 1905, became one of Einstein's staunch critics, especially because of his Jewish origin and his radical ideas. Lenard led the movement of Aryan physics under the Nazi regime, denigrating Einstein and other Jewish scientists. At the same time, Einstein enjoyed the support of some of the most distinguished physicists, such as Planck himself, Arnold Sommerfeld, and later Robert Oppenheimer in the United States. This network of colleagues not only propelled his career, but was vital in the validation and expansion of his theories. The era of Einstein was also the era of Planck, Bohr, Heisenberg, Schrödinger, Dirac, Curie, and Rutherford, to name just a few. Never before or after has physics experienced such a radical change in so few years. Between 1895 and 1930, the structure of matter was reformulated, time and space were redefined, and the door was open to modern technologies of nuclear energy, solid-state electronics, and advanced astrophysics. Einstein was aware of being part of a unique generation, and he always valued the exchange of ideas, although he often disagreed with his quantum colleagues. For him, the confrontation of perspectives was the very essence of scientific progress, and he often emphasized that the greatest enemy of science was not ignorance, but the illusion that the ultimate truth had already been reached. Thus, the greatness of Einstein cannot be understood without the historical context and the brilliant community of scientists with which he interacted. The end of the 19th century and the first decades of the 20th century were the stage for intellectual collisions that shook the foundations of classical physics. Amid this whirlwind of ideas, Einstein shone with his own light, but he also nourished himself from the work of predecessors like Lorentz, Poincaré, and Planck, and tirelessly dialogued with contemporaries like Bohr, Born, and Curie. This golden age of physics not only transformed our vision of the universe, but also laid the foundations for today's science and technology, turning Einstein and his colleagues into true legends of scientific history. Albert Einstein not only left an indelible mark on the history of physics, but his image, his phrases, and his distinctive personality turned him into a media figure and a cultural icon that continues to be present in the 21st century. Let's see how Einstein's figure has permeated art, advertising, cinema, and even everyday language. When we talk about Einstein in popular culture, it is almost impossible not to mention the famous photo in which he is sticking out his tongue. This image was taken by photographer Arthur Sass on the 14th of March, 1951, precisely on Einstein's birthday at the end of an event where the scientist was tired of cameras. The moment captured by Sass became an irreverent and friendly icon, a portrait that symbolizes the rebel scientist and has been reproduced on countless posters, t-shirts, mugs, and all kinds of souvenirs. Einstein was so delighted with the photograph that he requested copies to send to his closest friends as a kind of personal card with a touch of humor. Cinema and television have exploited Einstein's image in very different ways. Documentaries and biographies, from classic productions by BBC and Discovery to current series on streaming platforms like Genius by National Geographic, Einstein's life has been portrayed on multiple occasions to highlight both his scientific and personal facets. Cameos and fictional appearances. Einstein appears as a character or reference in numerous movies and series. In the comedy Night at the Museum 2, 2009 for example, there are Einstein bobbleheads that come to life and are part of the comedic gag. In Back to the Future, 1985, Dr. Emmett Brown's dog is named Einstein in honor of the physicist. Animated series. The cartoon version of Einstein with his white mane and mustaches become a recurring resource to evoke the idea of the crazy genius or eccentric sages. Series like The Simpsons, Futurama, or Family Guy have parodied or made nods to his figure in some episode. Einstein's fame has not been limited to the academic field. His face and name have been used in advertising and marketing campaigns. Ads that evoke genius. Many brands have used the image or a caricature of Einstein to convey ideas of creativity, intelligence, or innovation in their products. Licensing and image rights. The Hebrew University of Jerusalem, heir to Einstein's image rights, receives requests from companies wishing to commercially exploit his name or photograph. Curiously, Einstein remains year after year on the list of highest-earning deceased celebrities, according to Forbes, due to the royalties paid for using his image. Einstein's popularity is also evident in everyday language. Phrases like "you're no Einstein" or "wow, you're a real Einstein" are used to emphasize irony or highlight someone's intelligence. His quotes, sometimes verified and other times apocryphal, circulate massively on social networks, motivating people to reflect on imagination, curiosity, and creativity. One of his most recurrent phrases, although often taken out of context, is, "Imagination is more important than knowledge." This type of statement has deeply penetrated pop culture and appears in motivational posters, greeting cards, and inspirational ads. Different artistic movements have also reinterpreted Einstein's figure. References in music. From songs that mention his name to concept albums of progressive rock, Einstein appears as a symbol of the pursuit of knowledge or as the paradigm of the outsider who revolutionizes the world. Murals and graffiti. In many cities around the world, Einstein's face decorates walls with sometimes realistic, other times psychedelic representations, almost always exalting the creative spirit of the scientist. Pop art. Artists like Andy Warhol have included Einstein's image in their works, reinterpreting it within mass culture and placing him on the same level as icons like Marilyn Monroe or Elvis Presley. The word Einstein has become a universal synonym for genius. Often, in informal conversations, his surname is used as an adjective or metaphor. Expression. "It doesn't take an Einstein to understand it," indicates that something is simple and anyone can understand it, even without having a brilliant mind. In literature and the press, the comparison "he is the Einstein of our time" is frequently seen to talk about a distinguished scientist or innovator. The strength of Einstein as a cultural icon lies in the combination of his scientific genius with his relaxed and friendly image. A kind old man who stuck out his tongue at photographers and played the violin to disconnect from stress. He represents the romantic idea of the sage who, despite his highly elevated thoughts, retains the humor and simplicity of everyday life. Thus, Einstein is not only an essential part of the history of science, but also of pop culture. Beyond his theories about the universe, his face and name remain in advertising, television, cinema, literature, and in everyday expressions of thousands of people who, perhaps without knowing the theory of relativity, instantly recognize the genius and nonconformist character of this great scientist. In summary, Albert Einstein is one of those few historical figures who have transcended their professional field to become a universal symbol. His legacy in science is undeniable, but his cultural legacy is equally powerful, inspiring artists, creatives, advertisers, and millions of people who see in his image the most authentic representation of human curiosity and intelligent irreverence. What about you? Where have you recently seen Einstein appear unexpectedly? Tell us in the comments and continue exploring with us this fascinating intersection between science and popular culture. Albert Einstein died on the 18th of April, 1955, in Princeton, New Jersey. Until the last moment, he maintained his passion for the great questions of the cosmos. Even on his deathbed, he was supposedly still writing equations in a notebook. His body was cremated, but his brain was preserved for scientific studies, in the hope of discovering the formula for his genius. Beyond his immense contribution to physics, Einstein leaves us a message of constructive rebellion. Dare to question established dogmas, seek beauty and harmony in natural laws, and keep curiosity alive regardless of age or external criticism. His image transcended the borders of science and became a symbol of human creativity. As he himself said, "The mind is like a parachute. It only works if it's open," an invitation not to settle for the established and to open our minds to the unknown. Thank you for joining us on this extensive journey through the life, work, and curiosities of Albert Einstein, a man who reminds us of the value of creativity, the passion for truth, and the commitment to humanity. Einstein forever changed the way we conceive space, time, and energy. But behind that genius, we find a man with a great sense of humor, a violin in tow, and a heart that suffered for the injustices and horrors of his time. His theories continue to inspire new generations of physicists, while his anecdotes show us that genius is not incompatible with simplicity or everyday forgetfulness. What do you think of this incomparable genius? Have any of his anecdotes or reflections surprised you? Tell us in the comments which one you liked the most. If you like this content, give us a like. Don't forget to subscribe and share this documentary with other curious minds about science and history. Keep your passion for discovery alive, because, as he himself said, imagination takes us to worlds that do not yet exist, while knowledge anchors us to the present. See you next time.